Okay, this is part 2, looking at Unit 2B and dealing with an extension of our unit conversions. So now we're going to be talking about conversions between metric and the United States customary system. And these are not straightforward numbers, so again, these are not things you need to necessarily memorize. But if you read the little blurb that I've got right here, kind of gives you a little bit of insight and some things that may be helpful. But sticking with this table, referencing this table will be something that we will be using as a reference, and again, not as something to memorize. So don't worry about memorizing that. So we'll use different information based off of the problems we're given. So let's look at a couple of problems here. So we have a bag of garden soil. It weighs 40 pounds. So, whoops. So I'm just going to hit or write that one bag equals 40 pounds and holds 2 cubic feet. So one bag is 2 cubic feet, so feet cubed. And we want to find the weight in kilograms and the volume. So first we're going to find the weight here. So we know that one bag, we are going to first, we want to find 40 bags. So we know that, holy cow, read the problem, 15 bags. Okay, so we're looking at 15 bags, and we know that, again, I want to put my bags in the denominator so those cancel. One bag is 40 pounds. So that's going to cancel my bags, but then I now need to look at the conversion from pounds to kilograms, because again, the unit that I want in the end is kilograms. And so coming up here, we can see right here that 1 pound is 0.4536 kilograms. So we're going to say 1 pound is 0.4536 kilograms. Okay, and now you're going to multiply out the top and you're going to multiply out the bottom. And we're going to get 272 kilograms. I apologize for the little jump there in the video. So the 15-pound bag is going to weigh 272 kilograms. So there's our conversion there. Again, that's just multiplying the fractions across. And so the next thing we're going to be looking at is our volume here. Whoops. So the volume, again, we're looking for 15 bags in cubic yards. So we're going to start with the 15 bags. And we know that right here, this information, one bag is 2 cubic feet. That information was told to us, so I'm going to again put bags in the denominator so that they cancel those units. So 2 cubic feet is one bag. And then we are going to cubic yards. So this is actually the this is all in English measurements here, but I want cubic feet down here and cubic yards up here, and you would need to scroll up to our English measurements and see that 1 cubic yard is 27 cubic feet. So we are going to use that information. So we have 1 cubic yard is 27 cubic feet. So you would do 15 times 2 over 27. Okay, and this is going to give us approximately 1.1 cubic yards. Again, the bags will cancel in units, the cubic feet will cancel, and we'll be left with cubic yards. And I should have mentioned that up here, that bags cancel, pounds cancel, and we're left with kilograms. So that's doing a little bit of conversion between metric and just our standard United States customary system. And again, don't have to have all that memorized. Those tables will be provided on your problem sets that you'll be working on in my math lab. Now, let's look at one more here. So we got a Nimitz class, nuclear-powered aircraft carrier, has a top speed of 30 knots and a displacement of approximately 102,000 tons. So we want to express the top speed in miles per hour and the displacement in metric tons. Okay, and it gives us this information here that 1 knot is 1 nautical mile per hour, and a metric ton is 1,000 kilograms. So that's going to be key information that we need. So first, we've got 30 knots. So I'm going to say that's 30. I'm just going to say nautical miles per hour. Okay, and then we're going to multiply this by, if you look up in the table above 6,076.1 feet is 1 nautical mile. So a nautical mile is a little bit bigger than a standard mile. Okay, so that's going to convert us from nautical miles to feet, but then we need to go from feet to miles. So there's 5,280 feet for every 1 mile. And so notice that that cancels out nautical miles, that cancels out feet, and that gets us to miles. So we've got the miles part down. Now we've got to get, well, per hour. And notice that we started in hours, and so we don't need to convert any units there because our time units are good. So when we multiply all of this out and divide, you should get 34.5 miles per hour. And that's the speed at which this nuclear-powered aircraft carrier will be traveling at a top speed. Okay, the next thing we're going to be looking at is displacement. And that's kind of looking at the weight of 102,000 tons. And we want to figure out how much is this in metric tons. And a metric ton, again, is 1,000 kilograms. So we have 102,000 tons. So we need to, first, we're going to convert from tons to pounds. So we're going to go 2,000 pounds is 1 ton. So we want those tons to cancel. And then we're going to use the conversion that we used before, which was 1 pound was 0.4536 kilograms. Okay, and that's going to cancel out our pounds. And then we're going to multiply that by this idea that, again, 1 metric ton is 1,000 kilograms. So 1,000 kilograms, I want that on the bottom so kilograms will cancel, is 1 metric ton. So again, kilograms cancel, pounds cancel, tons cancel, and we got to multiply all of this out, divided by 1,000. You're going to get roughly 92,534 metric tons. Okay, and that's a conversion from tons in our standard system to metric tons. So again, it's all using all these conversion factors I'm pulling from these tables up here. And again, those tables will be provided on your homework problems. So I'm going to check on my time here. Okay. So next we're going to look at conversion from temperatures. And I do have in here this idea of a Kelvin scale. The unique thing about Kelvin is 0 degrees Kelvin is what we call absolute zero, where molecules basically do not, they can't move, It's the coldest possible temperature that can be obtained, but we're not going to be dealing with Kelvin. I just wanted to bring that idea to your attention. We're going to be strictly in Fahrenheit and Celsius. So you can see, different scales here. The freezing point for Kelvin is 273.15. 0 degrees Celsius, very convenient, is freezing. And 32 degrees Fahrenheit is freezing. 212 is the boiling point in Fahrenheit. 100 degrees Celsius is the boiling point there in Celsius, and 373.15 for Kelvin. But again, we're only sticking to Fahrenheit and Celsius, so we need to convert back and forth, and those conversions can be found right here. Okay, to go from Celsius to Fahrenheit, the Fahrenheit will equal 1.8 times the degrees Celsius plus 32. And then degrees Celsius, just make sure you're careful in your order of operations. You take Fahrenheit minus 32 and then divide by 1.8. Sometimes you will see these numbers as 9/5 and 5/9. Just depends. This textbook uses 1.8, but just so you're aware, when you see 5/9 and 9/5, those are equivalent fractions to those decimals. Okay, so for this video, we're just going to be doing parts A, B, and C. We're just going to convert. So we want to convert 45 degrees Fahrenheit to Celsius. So again, we want to go to Celsius. So we'll say in degrees Celsius, this is going to be 45 minus 32 divided by 1.8. Okay, so it's going to be 13 divided by 1.8. And then when you do that in your calculator, you will get 7.2 degrees Celsius. Okay, so again, that's just using this formula right here. Okay, that's part A. And hopefully that makes sense. When you look at 45 degrees Fahrenheit, Celsius, you would expect to be smaller. And so that's one way to make sure that things are going well. Okay, the next one, we want 20 degrees Celsius to Fahrenheit. So we're going to be Fahrenheit equals 1.8 times by 20 degrees Celsius plus 32. So make sure you do 1.8 times 20 first and then add your 32 and you'll get 68 degrees Fahrenheit. Okay. Now sometimes people worry about what happens when I have a negative, and you just keep doing everything the same when you have negative. So if I have negative 15 degrees Celsius and I want to go to Fahrenheit, I'll say Fahrenheit is 1.8 times negative 15 plus 32. And that will give you 5 degrees Fahrenheit. So just trust the calculations there. Don't worry about the derivation or where they come from. Just trust them and make sure you do your order of operations correctly. So that'll end part 2. The last part we'll be talking about is energy and power and those units.